In this video we'll be looking at 3C, applying Pythagoras' theorem. So the key idea is here that when we apply Pythagoras' theorem, we follow the following steps. The first one is to identify and draw a right-angled triangle that may help you solve the problem. The second step is to label the sides with their lengths or with the letter if the length is unknown. The third step is to use Pythagoras' theorem to solve for the unknown, and the fourth one is to solve the problem by making any further calculations and answering in words. So we're going to walk ourselves through this example first, and then we'll give one of them a try. So two skyscrapers are located 25 meters apart, and a cable links the tops of the two buildings. Find the length of the cable if the buildings are 50 meters and 80 meters in height. Give your answer correct to 2 decimal places. So we've got two buildings here. We can see they're separated by 25 meters, and there's a cable that needs to connect to the top of each building. So what we need to do is you need to find the difference between the height of the building. So we can see here that one of them is 80 meters and the second building is 50 meters. Therefore, the difference must be 30 meters. So that gives you the top here. The distance between the bottom of each building is going to be 25 meters, which is going to make up this bottom section of this triangle. And the length of the cable, we're going to label that as X. Now you'll notice that we've actually made a right angled triangle here. Okay, so side length of X, 25 and 30. So we're going to represent that diagram on the left side here. Let X meters be the length of the cable, and we are going to label this as 25 and this as 30. So applying Pythagoras' theorem, you guys should be quite familiar with this now. C squared equals to A squared plus B squared. C squared, we're going to change that to X. A squared is going to be 25 squared. B squared is going to be 30 squared. If we add 625 and 900, we get 1,525. And if you square root that, you'll get 39.05 to 2 decimal places. So that's how we find the length of the cable. You need to make your own triangle with the data that you've been given. So let's try one ourselves. Two poles are located 40 meters apart and a rope links the tops of the two poles. Find the length of the rope if the poles are 15 meters and 21 meters in height. Give your answer correct to 2 decimal places. So we know they're 40 meters apart. So one of the poles is 15 meters tall and the other one is 21. So let's try this ourselves. That's one pole. We're going to label that as 15 meters. This is a second pole. We're going to label this as 21 meters. We know that they are 40 meters apart. So the distance between here and here is going to be 40 meters. Okay. So we also need to find the length of the rope. Now, where does the rope actually tie? It ties to the tops of the two poles. So that's the rope, that's the top, and this is also the rope. Okay, it also needs to tie to the top of that pole. Okay, so what you can see here is we can actually create a triangle from this. So there's a right angle here, and let's isolate this triangle to the right side. Exactly what we've drawn. We know that the length between these poles are going to be 40 meters, and we know that the top of this section here is actually going to be the difference of 21 meters take away 15 meters. Can everybody see that? So this is going to give me a value of 6, and we can label this as X. So once again, it's going to be C squared equals to A squared plus B squared to work out X. X is going to be C squared equals to A squared. So let's just label that as A, and we'll label that as B. So A squared is going to be 40 squared plus B squared, which is 6 squared. Okay, so X squared equals to 1600 plus 36. So X squared will be equal to 1636. Find the square root of that. And I should get a value of 40.45 meters, correct to 2 decimal places. Alright, so that's it for this video. Hopefully you learned something. I'll see you on the next one.